Hello guys, welcome back to another video of An Average Programmer. Today we will solve Leetcode's daily challenge problem 1408, string matching in an array. And what we need to do is to identify all the words that are substrings of the words that are in our input. I'm going to be using a drawing to explain this better, but let's say that this exercise is marked as an easy problem, but it's not as easy as reversing a linked list or finding a duplicate element in an array. It's a little bit trickier because we have to see how to optimize the brute force approach. So for doing this, I'm going to be sharing with you the brute force approach and also the optimized version. So let's go and see our board. I'm going to be using the first example. So I already have all the words over here in my array, which are mass, as, hero, and superhero. And the brute force approach consists on comparing all the words with all the words. So this is going to be costing us a quadratic time complexity, which is not ideal, but in each comparison, we will have to be identifying if the length of the J word is bigger than the length of the I word. I'm going to be saying that all the words that are in this first row are going to be considered as I, and all these other words that are in the second row are considered as J. So J length has to be bigger than I length, and we have to also identify if J includes I. And if that's the case, then we will have to push that value to our result array. But what's the problem with this? The problem is that, as I mentioned, this is going to be costing us a quadratic time complexity. And additionally to this, the function of include could take us a lot of time complexity too. So this is not the best scenario. So I'm going to explain you the optimized solution. So there are three techniques that we can use to optimize. Well, this is not going to be the case for this problem in a specific, but in most of the array problems, sometimes we can optimize the solution with hash maps or with sets. But in this case, the best thing that we can do is to sort the array of words. Why are we going to be sorting this? Because it is going to be reducing the amount of comparisons that we will have to make in our words. So let's say that this will be costing us a time complexity of n log n, because let's say that we will use merge sort or quick sort, and let's say that we are using quicksort. So this is going to be costing us n log n, and after that it's going to be easier for us to compare our words, because here we will be comparing is as included in mass or in hero or in superhero. Yes, as is included in mass. And what happens if we found a word? Then in that case, we will just push as, and we will break, or we will continue to the next loop, which is going to be starting at mass. And how are we going to be sorting our array? We're going to be ordering it by the length of the words, because that's going to be the best case to avoid these validation that we have in our brute force approach. Okay, so I hope that was clear for you, and let's go and start typing the code. So the first thing that I'm going to be doing is I'm going to sort my words array. I'm going to be using the sort function, and I will have to pass A and B, which are going to be the two elements that we're going to be comparing, and I want to order them by the length. So I'm just going to be saying that I'm going to be ordering them in ascending order. So it's going to be like this. Okay, so this is the way to sort the words. Once we have this, let's create our variable for our result, which is going to be an array of a string. And this is also marked in the output of my function, which is over here. array of a string. Okay, so result is going to be let because I'm going to be pushing the elements to my array. So once we have this, we will have a double loop. One is going to be starting at index 0 and it's going to stop before the length of the words. So I'm just going to be saying that I will be incrementing I in each iteration. And our second loop is not going to be starting in 0, 2, because as I mentioned, we are trying to reduce the amount of comparisons. So I'm going to be starting j in I plus 1. Okay, and I'm going to be saying that that j is going to be we're going to be iterating until j is less than the word's length. Sorry, I'm missing an s over here, and I'm going to be increasing j in each iteration, and I'm just going to be saying that if the words in the index j includes words in the index I, then that means that that is a substring of the word. So in that case, I'm just going to be pushing that word to my result array. So let's say that we will have words in the position of I. I'm missing also an S over here, sorry. And I'm going to be passing to the other index because we already found a substring of a word. So that is going to be it, and then we will just be returning the result array. So just by reviewing our code, the first thing that we're going to be doing is sorting our words array by the length of all the words. After this, I'm going to be creating my variable, which is going to be an array of string. It's going to be initialized as an empty array of strings. And I'm going to be having my my for loop. Here I'm going to be adding also a nested loop to that initial loop. But in this case, it's going to be starting at I plus 1, and it's going to be having the same boundary as the first one, which is going to be the word's length. I'm going to be incrementing j, and I'm just going to be having an if statement to say that if words j includes words I, then I'm going to be pushing that to my result array, which is going to be words I, and I'm going to break. So let's run all our test cases. They should be passing. Yeah. And if I just submit the solution, this should be good. Okay, so I hope this was clear for you, and I'm going to be leaving also the solution in the comment section. So if you like this video, don't forget to put your thumbs up, and see you in another one.